All right, so continuing this second part of the fourth part of probability. A date in the month of September is chosen at random. Find the probability that is an even numbered date, given that it is before September 20th. So, yeah, we want an even number given that it's before September 20th. This is one where it's probably easier not to do the whole thing, but September has 30 days, and so the probability of getting an even number in our first in our 30 days is 15 out of 30. And oh, sorry, I apologize. That's our overall probability of getting an even, but we want to do even and before the 20th. So that's actually ends up being 2 through 20. So that ends up being 10 out of the 30 days in September. And then find the given that it's before the 20th. Okay, so then that is out of the 20. Out of 30, which ends up being just basically 1/2, 10 out of 20. And that is 1/2, or 50%, or 0.5. Any of those would be fine. So that would be the probability that you get an even number date, given that it's before September 20th. There it is. All right, I knew I screwed something up here. Given that it's before September 20th, so that actually reduces this slightly. So we don't want the 20th included. We're really going through the 19th. So there it is. So that actually should have been 9. And that makes this fraction not so nice. So it ends up being 9 out of 20. Or 9 out of 19. Ooh, there we go. Because it's out of before the 20th. So 19. And so does not reduce. 9/19. So before keyword there. The probability of Jasmine studying for a test and getting an A is 13 out of 16. If the probability that Jasmine studies for the test is 9 out of 10, find the probability that she will get an A on the test given that she studied. So we want studied and get an A, which is this fraction here, 13 out of 16, divided by, I'm going to do a little diagonal slash here, and that the probability that she studies for the test, which is 9 out of 10. So 90% chance she'll study for the test, and then the probability that she'll study for a test and get an A is that, and so the overall probability of getting an A, given that she studied, is that fraction. So that one, we can, if we want to leave it as a fraction and we want to remember do this by hand, we can do the 3/16 times 3/16 times 10/9, right? And then, so this ends up being 30 over 16 times 9, 144, which that'll reduce a little bit. So 30 over 144 reduces to 5/24 for that one. Yep, and it looks like I made a mistake there. I just did 3 over 16, so that should have been 13, and so that changes this up a little bit. Sorry, this should have been 130, which is not going to reduce to that. 130 over 144. 130 over 144. Math frac is 65/70 seconds. Not as nice. 65/70 seconds. Sorry about that. A car lot has both used and new cars. If 86% of the cars on the lot are new and 45% of the cars are new and have a sunroof, find the probability that of randomly choosing a car with a sunroof, given that it's a new car. So 45% chance. I'm going to do these as decimal. You could technically get away with doing these as a percent, but decimals are really once you're doing math, I would turn your percents into decimals. So that's 45% chance that it's both new sunroof, new and has a sunroof, divided by the overall probability that it is new, so 0.86. And so we can divide those up. So we actually can get a pretty nice fraction with this. 0.45 divided by 0.86 is, I guess it's just going to be that, 45 out of 86. And if you want a probability, since they worked the problem in decimals originally, if you want to go with the decimal, it's 0.5233, go there, or 52.33% chance. So given that it's one of those 86% new cars, 45% of those 86%. I don't know, it's not exactly 45% of those, but that fraction ends up being the percent that actually have sunroofs, pretty likely. All right, and then this last bit, we can use Venn diagrams to help with this. So a group of people were asked if they drink coffee or tea. The results are shown in the Venn diagram to the left. If one of the people surveyed is chosen at random, find each probability. So find the probability that they drink coffee given that they drink tea. So I'd like to focus in on this. So I'm going to focus in on the tea group here. So one way you can do this is realize that you're limiting it. You're given that they drink tea. So out of those, you can just actually kind of do it straight away. Out of those 16, the proportion that drink coffee is 12 out of those 16. So we can think of it as a reduced sample space. That's one way of doing it. Another way is following that same formula, right? So the probability that they drink coffee and drink tea, which is the overlap, 12 out of, and then the entire number we have to add all up. So 24 plus 12, 36, 40, 50. So 12 out of 50 divided by, and then the probability that they overall drink tea is 16 out of 50. And notice that, like the 50s effectively cancel, and you're left with 12 over 16. So it really is, 12 out of those 16 that given that they drink tea, that they will drink coffee. So show you that way, but in the future, you can just kind of go straight to it. 12 out of 16, which reduces to 3/4 or 0.75 or 75%. All right, so then erase that. The next one, the probability that they do not drink tea given that they drink coffee. So we could do not drink tea and drink coffee, which is 24 out of 50, and then do a similar thing. But I'm going to just do this one a little bit differently, given that they drink coffee. So out of this group, which is 36, what percent do not drink tea? So 24 out of those 36 do not drink tea. So not tea means they need to be not in that tea circle. So 24 out of those 36, and that reduces to 2/3. Next one, probability they do not drink coffee given that they do not drink tea. So the non-tea drinkers, it's not as easy to see the space, but it is these folks out here. So out of those 34, what proportion do not drink coffee? And so those would be the 10 out of those 34. So out of the 34 that don't drink tea, 10 don't drink coffee. So 10 out of 34, which will reduce to 5/17. All right, and so the next one, of the 400 freshmen at Westview High School, 92 students are in band, 60 students are in chorus, and 20 are in both band and chorus. The students chosen at random find each probability. So before I do that, let's go ahead and draw a Venn diagram out here. So we've got band and chorus. Get our overlapping circles going. All right, we got our entire sample space in the box. And so where I would recommend starting if you're drawing a Venn diagram is the overlaps. 20 students are in both, so 20 are in both. And so we have 92 students are in band, and so the total circle of band should have 92. So if we do 92 and then subtract away the 20 that are also in chorus, that leaves us 72 that are over here. So ultimately have 92 in band, 72 that are in band not in chorus, 20 that are in band and chorus. And we can do the same thing with chorus. 60 are in chorus. That means we'd have 40 here and 20 there. So that adds up. And then the last thing we need to add up is the 400 total freshmen. So I'm going to do this, 400 minus the 72 minus the 20 minus the 40. There's that many kids left that aren't in either. So the 268, we'll put out here, 268. All right, so now we can answer some of these. What's the probability that they're in chorus given they're in band? So out of those 92, that would be our denominator. Out of those 92 that are, given that they're in band, probably they're in chorus is 20 out of 92, which we can reduce to 5/23. The next one, probably that they're not in band given that they're in chorus. So given that they're in chorus, so given that they're one of those 60 people in chorus, what's the probability that they're not in band? So that would be the 40 out of the 60. Of the 60, this is kind of our reduced little bubble we're focused on. And of course that will reduce to 2/3. And then the last one, in band, given that they're not in chorus. So the not in chorus part is, let me change this up. Not in chorus would be these two values there. So if we add those up, that's going to end up giving us 340. So because it's, I just did the 400 minus the 60 here that are, so minus the 60 are in chorus. So there's 340 students that are not in chorus. Out of 340, the proportion that are in band is 72. So not including the 20, just the 72 out of that 340. Right, that's what this was. And so then that reduces to 18 out of 85. And you can do that as decimal or percent as well.